In this learning unit, we will focus on the concept of chemical bonding. I believe you all have learned this before during your foundation or STPM or matriculation. Okay, let's take a look on the definition of the chemical bonding. So chemical bonding can be categorized into three different groups, which is ionic bonds, covalent bonds, and metallic bonds. Ionic bond involve electrostatic forces that exist between ions with opposite charge. Normally, when a molecule forms ionic bond, it involves a metal or a cation with a non-metal or the anion. It involves the electron donating and accepting process. And then the second chemical bonding is covalent bond, which is a formation by sharing electrons between two atoms, and it usually involves non-metallic element with another non-metallic element. While the third one, which is the metallic bond, it is a bond that normally involves between metals, and in this bonding, electrons are free to move around throughout the three-dimensional structure. So normally, the chemical bonding are represented by Lewis symbols and the octet rule. Electron dot symbol, or known as Lewis symbol, in which this kind of drawing using dot as the electron valences in an atom. For example, if we take an oxygen, the electron configuration of oxygen is 1s2, 2s2, 2p4. So when two oxygen atoms sharing their electron, they will form gas O2, which involve the sharing of 4 electrons. So when there are 8 electrons at the orbital valences in an atom, it can be said as obtaining the octet rule. And atoms tend to lose, gain, or share electron until they are surrounded by 8 valence electrons. Okay, if we look at the oxygen molecule here, one of these oxygen already has reached octet, meaning there are 2 electrons here, 2 electrons here, and 4 electrons here, so it will give you 8. And then the other oxygen also has 8 number of electrons. Okay, now we take a look at resonance structures. Yeah? When we draw a chemical symbol or Lewis dot electron, there are also a phenomenon or a structure that is what we call as resonance structure. Resonance structure represents all possible Lewis structure for a molecule. For example, here NO2 can either be drawn this way or this way. One of the oxygen can be interchanged. One is double bond and one is single bond. So normally, when we look at resonance structure, let's say we have two resonance structure like this. So how are we going to identify which resonance structure is the correct one? So how are we going to identify is by calculating the formal charge of the structure. The most correct Lewis structure will be structure where the formal charges are evenly distributed throughout the molecule. In this case, we will look at every atom and we will look at the formal charges of every atom in the resonance structure. And the sum of all the formal charges should equal to the total charge of the molecule. Let's say the molecule is CO. Okay, CO does not have any charge, meaning formal charge of C plus formal charge of oxygen plus oxygen, it should be 0. It should be 0 because the CO molecule does not have any charge. Okay, what is formal charge? Formal charge is the difference between the number of valence electrons of each atom and the number of electrons the atom is associated with, and the equation takes the form of Fc equivalent to number of valence electrons were isolated, means it's the ground state, and then minus number of unshared minus number of shared electron divided by 2. So the best Lewis structure for a molecule should follow this formal charge rule. So the first rule is formal charge of each atom should be equal to 0. And the second rule, if it is not equal to 0, negative formal charge must be coming from the most electronegative atom. Okay, I'll show you example at the next slide. Okay, let's take a look at carbon dioxide, which has 1 carbon and 2 oxygen. Okay, this is the resonance structure A, and the second structure is the resonance structure B. Okay, if we look at A, the Fc of oxygen 1, it is 0, 0, and then the Fc of carbon in the middle here is also 0, and Fc of oxygen here is 0. And then when we look at the structure B, the formal charge of oxygen number 1 is plus 1, and the formal charge of carbon is 0, and the formal charge of oxygen number 2 is minus 1. So if we look at the structure, okay, so how do you get this number? So you need to use the formula of the formal charge in the previous slide. So structure A here fulfills the rule number 1, where all the formal charges of the atom is equal to 0. So structure A is the best Lewis structure for carbon dioxide.